Good morning, guys. Today we'd like to do a little work getting you kind of ready for second trimester. Let's talk about angles of polygons today. Our objective for the day is that you'll be able to find the sum of the measure of the angles of a polygon. You'll also be able to find the measure of interior and exterior angles of a regular polygon and determine the number of sides a regular polygon has if you know the angle measure. Well, let's talk about polygons. And remember, polygons are a closed figure, like a triangle is a polygon. Two types of polygons, convex and concave. Notice how concave kind of has an indent, kind of like when you go into a cave. And our names, your vocab. Remember, three-sided polygon is a triangle. A four-sided polygon is a quadrilateral. Now, there's different types of quadrilaterals, which we'll study a lot coming up in the second try. Five-sided polygon is a pentagon, then hexagon, septagon, octagon, nonagon, and a dodecagon. Anything we get past 10, we just simply say it's a polygon. Or like a 15-sided polygon is just a 15gon. By the way, this should be decagon, not dodecagon. So a little vocab for us today. Back up the slide here, I went too far. A diagonal. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. Okay. Now, triangles don't have diagonals because all their vertices are consecutive, but anything after a triangle, quadrilaterals, pentagons, etc., you can draw diagonals. So notice in this shape, this pentagon, we have a diagonal. Connects A, and this would be C up here. Also A connecting to D. Take a look at this one. F to H is diagonal because it connects two non-consecutive vertices. And if you notice, when we draw in the diagonals, all the ones from one particular vertex, we've broken the polygon up into different shapes that we should recognize. Triangles. Take a look at this. So here's a hexagon. I draw every vertex from vertex A. And notice that I break it up into 4 triangles. We know that a triangle is always 180, so if there's 4 triangles in a hexagon, 4 times 180 means there's 720 degrees in a hexagon. Take a look at this. It's a decagon. Again, I start at one vertex, and you can do this from any vertex you wish, and draw all the diagonals from that one vertex. So A to C, A to D, A to E, A to F, etc. And notice that we've taken the decagon, broken it up into triangles, which we know the sum of a triangle is always 180. 8 times 180. This decagon would have 1,440 degrees. That gets us to the polygon interior angles theorem. The sum of the measures of the interior angles of a convex n-gon. N meaning any number of sides that you wish, is n minus 2 times 180. So in this case, again, we have a hexagon here with 6 sides. So 6 minus 2 times 180, 720. And then we do problems like this. Find the missing angle measure of x. So the first step is we'll find the sum of the interior angles. Notice that it's a pentagon with 5 sides. So 5 minus 2, 3 times 180. The pentagon has 540 degrees. Find the sum of the known angles. So we add up the 113, the 117, the 112, and the 100 to get 442. Subtract 540 minus 442. That means we must have 98 degrees for the missing angle. We can also use it with solving for variables. Find the angle sum here. So again, we figure out what the whole polygon has to add up to. And if you notice, it has 6 sides, therefore it's a hexagon. 2, 3, 4, 5, 6. So 6 minus 2 is 6 minus 2 is 4 times 180. The entire polygon adds up to 720. Now we'll add up all the angles. So 6x plus x minus 8. Notice I'm starting here and I'm going to go around in a counterclockwise manner. 7x, 4x plus 14, 5x minus 6, 120. Combining all the like terms, the x terms, gives us 30x. Combining the constants gives us 120. And then we're just solving for x, a little two-step equation. And we find out that x equals 20. Now, an equilateral triangle is an example of what's known as a regular polygon. A polygon is regular if and only if it has congruent sides and congruent angles. So it has to be equilateral and equiangular. So an equilateral triangle, as I mentioned, a square is an example of a regular polygon. And now we talk about exterior angles. An exterior angle of a polygon is simply formed by extending one side. And if you add up the angles, all the exterior angles, one angle at each vertex, your sum will always come out to be 360. So we can do this. Again, notice that we extend at one angle per vertex. So 130 plus x plus 100 plus 30 plus x has to equal 360. And we discover that x equals 50. We also expect you to be able to work it backwards today. Given the sum of the measures of the interior angles of a polygon, find the number of sides. All the angles of this polygon add up to 2,340. How many sides does the polygon have? So notice we use our formula, 180 times n minus 2 equals, in this case, 2,340. So we'll distribute the 180n minus 360. Add 360 to both sides. Again, we're just solving the algebra equation from here. And we discover that n equals 15. We can also do it this way. Given that the measure of each interior angle of a regular polygon, find the number of sides. So every angle in the regular polygon is 144. So again, notice we take 180 times n minus 2, divide it out by n. Cross multiplying gives us 144n equals 180n minus 360. Bringing this over, 36n minus 360, adding 360, and we discover that n equals 10. Now, that's the hard way. There's an easier way, and that is this. If it's a regular polygon where all the interior angles are the same, every exterior angle is the same. So if the interior is 144, the exterior would be 36 because they're supplementary, because they form a linear pair. So we simply take 360 divided by 36, and we end up with 10. All right, that'll do today's lesson. I will post the Math XL assignment up for this in just a little bit.